Good morning, students. So, in this class, we will perform your experiment number 4 and its second part. Second part of your experiment number 4, which is your output characteristic for BJT common emitter amplifier. Okay. In the first video, we have obtained the input characteristic for the common emitter amplifier. Now we will obtain the output characteristic of the common emitter amplifier. So what step we will follow that I am going to explain all these steps. Okay, so you will click this same window you will get. You will go to simulation part, simulation tab, and once you have clicked the simulation tab, you will get these two options. Now you will go to BJT output characteristic. Okay, you will get this type of window, and here you can see the circuit diagram which I had already shown you for the output characteristic. That circuit diagram we are going to use here, and ammeter and voltmeter, they are placed just for visual appearance, just to show the reading. Okay, to and so this is the complete circuit diagram for the output characteristic, and same RH1 and RH2 are here used, and instructions are in this. When you just put your move your mouse cursor on this instruction tab, then you will get the instruction. So here what you will do, we are going to obtain the output characteristic. So firstly, the same step we will follow. We will set both the rheostat to 1 ohm, and just like this. And next step is you will set the base current to 15 microampere by adjusting the rheostat RH1. So you are going to set, initially the base current is 10.29, and you will set this base current to 15 microampere by adjusting RH1. So I will adjust RH1 and I will set IB1 to 15. Okay. So this will give you 15. You will not be able to get 15, but it will be around 15 point something like 35. Okay. Okay. So by default, you will not be able to get 15 microampere. You will be able to get 15.38 microampere. Then what you will do next, you will vary the collector to emitter voltage as it is written in the section number 3, and you will adjust RS2. Okay. So you will adjust RS2, and then you will vary the collector to emitter voltage. And the fourth step is you will note the reading of the collector current. And fifth is you will be plotting the plot between the common emitter configurations for output characteristic, and you will get the graph between VC, which will be along x-axis, and collector current will be along y-axis. Okay. Then after performing all these steps, you will set the base current to 20 microampere. Earlier we have set the base current to 15 microampere, and we have got the reading of VC and collector current, collector to emitter voltage and collector current. Now you will set the base current to 20 microampere. Again, you will get the readings of collector to emitter voltage and collector current. Okay. So you are going to take the readings of VCE and IC for different value of base current, 20 ampere, microampere, 30 microampere, 40 microampere. Okay. Now let us perform. Let us go to your step number 3. Okay. You will vary. You will adjust RS2 and little bit, and you will adjust RH2, and you will vary the collector to emitter voltage. Here we have got collector to emitter voltage 0.50 and collector current 27.79, and we have varied RH2. Now I will add these reading to table. Okay. So I'm getting these two readings for base current of 15.35 microampere. I've got collector to emitter voltage 0.5 volt and collector current by 27.79. Again, the same step I will follow. I will adjust RH2 and I will again add it to table. So this will be my second reading for same value of the base current. Then I will again vary it. Again I will get the same different reading for collector to emitter voltage and collector current. Okay. So in this way, I will be getting all these readings like this. Okay. Same step which we had followed for input characteristic. So here we are going to follow the same step for taking the different reading of collector to emitter voltage and collector current for same value of the base current. Okay. So you will be taking the around 20 readings for the in order to get a graph. Okay. So just let me complete this. And then develop. It will take 4 or 5 more. I hope you are getting how and how I hope you would have understood the way I have explained the different steps and how to get the output characteristic. Okay, so you will be doing like this. You can take around 20 readings. So we have got 20 readings and they are listed in this table. You have got all these readings for same value of the base current. Remember this thing. Okay, because base current is here is the input current and your collector current is the output current. And you are plotting the output characteristic. So you will be plotting the characteristic between output current and output voltage. Output current is collector current and output voltage is collector to emitter voltage. Okay. So if a question comes that what do you mean by output characteristic of the common emitter amplifier, that means the output characteristic is a graph between the output current and output voltage for different value of the base current. So these reading we have got for base current of 15.35 microampere. Similarly, you will you will be taking you will be setting this base current to different value like 16 microampere, then 18 microampere, then 20 microampere, 25, 30 microampere, and you will be getting the reading of collector to emitter voltage and collector current. Okay. So for different values, the base current starting from 15 to 25 or 30 microampere, you will be getting the different readings of collector to emitter voltage and collector current. So after you have finalized this table, you will click this plot and you will get this type of plot. So this is the output characteristic you can see for the common emitter amplifier. Or in brief, I can say this is a plot between output current, which is the collector current, along y-axis you can see, and collector to emitter voltage along x-axis for different value of base current. These are the different value of the base current. Okay, different value of the base current. So base current is initially it will remain constant like this. Okay, so when you are going to vary, when you are going to set the base current to 20 microampere, 16 microampere, 17 micrometer, so you will be getting the graph like this. So you will be getting different curves like this. Okay, above this curve. Okay, so this is the output characteristic graph or VI graph you can say for the BJT common emitter configurations. So same way, this you can plot or you can print by clicking this button, and it will ask you to save it as a PDF. Okay, so you can save in your desktop this complete page you will get in the PDF form. Okay, this is the graph for one by base current. Okay, you will be taking this plot for various value the base current. Okay, remember this thing like 15.35 microampere, 16 microampere, 17, 18, 19. Okay, so then you will be save this. You will click the save button and this graph it will be saved in your desktop. Later on, you can take the printout and paste it in your file. Okay. So this is the your experiment number 4, your BJT output characteristic for the common emitter amplifier. So I hope you would have understood. So if you have any doubt, you can ask me and you can put a question in the comment box. Okay, thank you.